Hi, it's Mrs. Nandor, and in this video we're going to be looking at our states of matter and how our states of matter change. So let's start with our three states of matter. We have solids, liquids, and gases. And the differences between our states of matter have to do with two main things: how the particles are moving and how the particles are arranged. So we know that particles move and they can move at different speeds, and so that's going to factor in as to what state of matter an object is in. It also depends on how the particles are arranged in their attractions between the particles. It's also going to affect their states of matter. So let's start with solids. So we know from previous experience that our solids have a defined shape and volume. A solid is an object that you can pick up and it's not going to likely fall apart. It's going to hold its shape and it's going to hold its volume. If we look at the particle level of a solid, the particles in a solid are very tightly packed together. So I'm going to draw some particles. Particles in a solid have a very orderly arrangement, and they're packed nice and tightly together. Now, the particles in a solid are also moving very slowly, so we have to come up with a way in our particle diagrams to show that particles are moving, and we're going to use something called whooshes. So I'm going to write that off to the side. And whooshes are used to show how fast a particle is moving. So if we have a particle with a really short whooshy, it means it's moving slowly. If we have particles with really long whooshies, that means they're moving fast. So in a solid, our particles are not only packed tightly together, they have strong attractions for each other. They are also moving very slowly. So I'm going to add short little whooshies to my particles. And now that all of my particles have whooshies, I have a particle diagram for a solid. So a couple of features: they're packed tightly together. That means it has a defined shape and volume. Particles in a solid have strong attractions for each other, and they're not moving very fast. Let's move on to a liquid. So a liquid, we know, has a definite volume, but it doesn't have a definite shape. It takes the shape of whatever container you pour it into. Solid is kind of the halfway between, or liquid is the halfway between a solid and a gas. So the particles are more spread out, but they're not super far apart. They're moving faster than a solid, but not as fast as a gas. And they definitely do not have an orderly arrangement. So let's draw some liquid particles. So not very orderly arrangement. They're not stacked like in a solid. They're spread farther apart than the particles in a solid. And now I have to add my whooshies to show that they're moving faster than my solid, but they're not moving very fast. So I'm going to give them kind of medium whooshies. Okay, so liquids have medium to low attractions between the particles. They have a definite volume but no definite shape. They don't have very strong attractions for each other, but there are attractions between the particles. No orderly arrangement. They're kind of spread out and they're moving kind of at a medium speed. Let's look at a gas, and the gas is the complete opposite of a solid. So the particles are spread far apart, has no definite shape, no definite volume. They're moving very fast, and there are essentially no attractions between the particles in a gas. So we're going to draw a gas to represent we're going to draw a particle diagram to represent our gas. So I'm only going to draw 3 particles because they're spread far apart. They're also moving very fast, so I'm going to draw long whooshies. And so now my gas particle diagram shows that they're spaced far apart. We know that because they're spaced so far apart, they have no attractions between the particles. They're moving very, very fast. Okay, let's look at how our states of matter can change. So we have our changes in state. We also call these phase changes. So those mean the same thing. If we're talking about changes in states of matter, or we're talking about phase changes, we're talking about going between solids, liquids, and gases, and then back the other way. So let's start with some of our transitions. So if we go from a solid to a liquid, we call that melting. And then if we go from a liquid to a gas, we call that evaporation. If we go back the other way, if we go from a gas to a liquid, we call that condensation. And if we go from a liquid to a solid, we call that freezing. So we often think of these changes in state, or these phase changes, happening at certain temperatures. For instance, we usually think that something has to be warm in order for it to melt. It has to be cold in order for it to freeze. And that's not necessarily true. These words just describe what type of change is happening. So anytime something is freezing, it's going from a liquid to a solid. Doesn't necessarily mean it's cold, it just means that it's going from a liquid to a solid. So let's talk about some of the things that happen on the particle level when these changes occur. So when we're melting, when we're going from a solid to a liquid, two main things have to change. So we have to change the speed of our particles. So the particles have to start moving faster. Particles in a liquid move faster than particles in a solid. So the speed of the particles has to increase. We also know that once that speed increases, they're going to move farther apart, and those attractions are going to lessen between the particles. So we're going to break some attractions, they're going to move farther apart, and the particles are going to be moving faster. That same thing happens when we go from a liquid to a gas, just a little bit more extreme. So they go from their medium speed to their very fast speed. So again, particles are speeding up. They're breaking all their attractions, and they're spreading much farther apart. When we go back the other way, when we go from a gas to a liquid, when we're condensing, our particles have to slow down, they're going to get closer together, and they're going to start to reform some of their attractions. Then when we go from a liquid to a solid, the particles will slow down even more, they will form much stronger attractions, and they will become tightly packed. So the things we talked about previously that differentiate between our states of matter, solid, liquid, and gas, are the same things that have to change when we're changing states. So we have to change the speed, we have to change the spacing and the arrangement, and that change in spacing and arrangement tells us that there's a change in the attractions between. So as we're going from solid to liquid to gas, we're breaking those attractions. As we're going from gas to liquid to solid, we're reforming those attractions.